Assalamualaikum warahmatullahi wabarakatuh.
Hello friends, my name is Intan Mei Setianingrum. You can call me Intan. I'm from Engineering Physics number 45.
Hello everyone, my name is Nurul Jabia. You can call me Dia. My student ID number is 023094.
Hello, my name is Andra Kurnia Putra. NRP 0231 1940 0087.
Hello everyone, let me introduce myself. My name is Renaldi Ramaja Udra Hanafi. My student ID number is 022308.
Hello, my name is Alivia Rita Putri Zazita, NRP 0231 19 4000 0031.
Hello, here we are as engineering physics students will explain what we learn in our department. In our department, we study about mathematics, physics, and the application of engineering. Associated as the discipline that bridges the gap between basic science and engineering, engineering physics has a very broad spectrum of courses from the upstream to down, includes the concept of ideas as far as its application. Student of the Department of Engineering Physics, Institut Teknologi 10 November, was provided with research and development, as well as design and analysis of industrial systems with specialization in instrumentation and controls, energy, materials, vibration and acoustics, and photonics. And from that specialization, we have several laboratories to support learning. First, we have Energy and Environmental Conditioning Laboratory. It is the special place to study and explore energy and environmental conditioning. To support the courses, that laboratory is divided into three specializations that are thermal and fluid engineering, renewable energy, and energy management and green building. First, I will explain about thermal and fluids engineering. In that specialization, we learn about the basic of Gambit software, software fluid, and software ANSYS. ANSYS mechanical finite element analysis software is used to simulate computer models of structures, electronics, or machine components for analyzing strength, toughness, elasticity, temperature distribution, electromagnetism, fluid flow, and other attributes. ANSYS is used to determine how a product will function with different specifications without building test products or conducting crash tests. For example, ANSYS software may simulate how a branch will hold up after years of traffic. The second is in renewable energy. In renewable energy, we learn about solar panel. The term solar panel is used colloquially for a photovoltaic module or PV. A PV module is an assembly of photovoltaic cells mounted in a framework for installation. Photovoltaic cells use sunlight as a source of energy and generate direct current electricity. A collection of PV modules is called a PV panel, and a system of panels is an array. Arrays of a photovoltaic system supply solar electricity to electrical equipment. And the third, in energy management and green building, we learn about how to calculate cooling load and how to set building to be a green building. Green building refers to both a structure and the application of processes that are environmentally responsible and resource efficient throughout a building's life cycle, from planning to design, construction, operation, maintenance, renovation, and demolition. Green building energy management solutions can significantly improve the energy efficiency of commercial buildings, making them more affordable, comfortable, and sustainable. Green energy management systems can also control lighting and temperature according to a set schedule. Lighting controls can range from basic systems that use time and zone controls to fully automatic central building management system that control all of the lighting and equipment in multiple facilities. HVAC controls can include an automatic tenant override system, so the tenants can remotely access controls in their section of the building.
Furthermore, one of the laboratories in Engineering Physics Department 10 November Institute of Technology is Computation and Cyber Physical System Laboratory. Computation and Cyber Physical System Laboratory is a certain laboratory built in the Department of Engineering Physics. Other than handling both practicums and educations, this laboratory also developed insight in the field of programming, multimedia, networking, web design, PC hardware, and engineering drawing. Research of the lab takes part in supporting the main fields of the department with its numerical, visual, interface, and even artificial intelligence basic. In this lab, there are 4 divisions, namely 1. Programming. Develop and build an executable computer program for accomplishing a specific computing task by taking an algorithm and encoding it into a programming language. 2. Web design. Design similar process of creation with the intention of presenting the content on electronic web pages, which the end users can access through the internet with the help of a web browser. 3. Networking. Control collection of computers, servers, mainframes, network devices, peripherals, or other devices connected to one another to allow the sharing of data. 4. Multimedia. Concerned with the computer-controlled integration of text, graphic, drawings, still and moving images or video, animation, audio, and any other media where every type of information can be represented, stored, transmitted, and processed digitally. Next, in this lab there are 4 research, namely 1. Internet of Things. Extension of internet connectivity into physical devices and everyday objects. Embedded with electronics, internet connectivity, and other forms of hardware. These devices can communicate, interact with others over the internet, and they can be remotely monitored and controlled. 2. Artificial intelligence. Simulation of human intelligence processes by machines, especially computer systems. These processes include learning, the acquisition of information and rules for using the information, reasoning, using rules to reach approximate or definite conclusion, and self-correction. 3. Robot vision. Technology and methods used to provide imaging, based automatic inspection and analysis for such applications as automatic inspection, process control, and robot guidance. Usually in industry using combination of camera hardware and computer algorithm to allow robots to process visual data from the world. 4. Augmented reality. Blending of interactive digital elements like dazzling visual overlays, bassy haptic feedback, or other sensory projections using technology to superimpose information, sounds, images, and text on the world we see. Computation and Cyber Physical System Laboratory carries out the computer programming practicum.
Right here, I want to talk about one of engineering physics laboratories. The engineering department has 9 laboratories as support for students' learning and research. One of them is Physics Engineering Laboratory, also known as Laboratorium Fisika Rekayasa in Bahasa. Physics Engineering Laboratory is one of supporting laboratories for engineering physics students. The Physics Engineering Laboratory advances a practice based on physical sciences which is implemented into technology. The laboratory is focused on lab works to support the theory learned in the class of Physics Engineering 1 and 2, Superlisis for first-year students. Physics Engineering Lab is relatively new as it first opened in 2016. The lab assistant is chosen from second and third year students. Well, the laboratory that is headed by Dr. Catherine Indrawati, STMT, consists of 5 divisions, namely Practicum Division, HRT Division, Project Lab Division, Media Division, and Lab Activity Division. Physics Engineering Laboratory has some various activities such as lab work, art grading, English Day, and maintenance day. The laboratory is equipped with basic tools of physics experiment such as digital scale, digital multimeter, analog multimeter, lens kit, wind turbine, electric bicycle, oscilloscope, etc. Each lab has its own focus field, so do Physics Engineering Laboratory. One of the focus fields of Physics Engineering Laboratory is the embedded system. Embedded system is a special system that designed to operate specific duty. The systems are real-time and widely used for digital equipment, such as digital scale, digital watch, etc. Next is the supervisory control. Supervisory control as the surveillance to efficiency control in industrial areas. Afterward, there is reliability control. Reliability control closely linked to safety and focusing on the preservation of life. And last but not least, there is the FTC, also known as fault tolerance control. Fault tolerance control as the designated design control.
This time I will explain about one of the laboratories in the Department of Engineering Physics, namely the Vibristic Lab, which stands for Vibration and Acoustic Laboratory. Vibration and Acoustic Laboratory in Department of Engineering Physics (ITS) learns about phenomena of sound and vibration, including human hearing system and its application, for example, such as speech synthesis, noise mapping, vibration analysis, and many more. Besides research, Vibristic Lab also provide consultation about vibration and acoustic, including indoor acoustic, vibration analysis, and speech synthesis, so that Vibristic Labs is able to compete with another professional consultant. In this lab, we have 4 branches of science that we majored in, namely architectural acoustic, machinery and vibration control, material for noise and vibration control, and the last one is underwater acoustic. However, this time I will only explain about material for noise and vibration control. The material for noise is simply the material that has the ability to reduce noise by means of absorbing, reflecting, or transmitting sound so that sound can be muffled and reduce the noise level. In this field of science, we study classes of sound transmission, transmission loss, sound absorption coefficient, and sound attenuation. Sound transmission class is the ability of the average transmission loss of a material to reduce sound from various frequencies. And the definition of transmission loss itself is the power of matter in holding or block sound over a certain frequency range. One of the products produced from this field of science is the sound barrier. The function of the sound barrier is to reduce the overall noise level, but not by reflecting or absorbing the sound itself.
Last, we will explain about physical measurement laboratorium. Like other laboratories, physical measurement laboratories were established to support learning in physical engineering department for lectures and practicum. This laboratorium developed knowledge in measurement system, calibration, reliability, safety, microcontroller, and embedded system field. This laboratory supports the areas of interest in terms of measurement, data collection, and understanding of instrumentation system. Every engineering physics student must take a practicum in this laboratory. In the third semester, the students will get electronic course in which to learn about analog electronics, digital electronics, and the fundamental basis of the microcontroller. In the fourth semester, students must follow the practicum in this lab again to deepen their knowledge on the measurement and calibration system course. During this practicum, students learn the concept of a measurement system so that they can analyze measurement based on their characteristics and carry out calibration activities. Activities carried out in this lab include 1. Practicum is the main activity of the laboratory, assisting students who will be practicing in physical measurement laboratories. 2. Calibration and lab tests. Physical measurement laboratories provide calibration service for measuring instruments to ensure they work according to standards. 3. Galleries photos. Physical measurement laboratory provides performance testing and protection service of a device according to existing standards. 4. DIY electronics. Design and develop embedded systems, analog and digital electronics that are capable of completing certain tasks. 5. Training. As a result of learning in the laboratory assistant seeks to share knowledge about electronics and measurement systems through training. 6. Achievement. Achievements achieved by members and the physical measurement laboratory. Actually, the engineering physics department has 9 laboratoriums. 5 laboratoriums which are fields of interest in engineering physics and 4 laboratoriums supporting fields of interest. Laboratorium that we have not yet explained include the Instrumentation Laboratorium, Materials Engineering Laboratorium, Photonics Laboratorium, and Instrumentation Workshop. The reason why we don't explain the other 4 labs is that until now we only visited the 5 laboratoriums that were described. Okay, maybe that's enough from us. We are just ordinary people who are not far from mistakes. If there is a wrong word from us, we can only say sorry. Thanks for your attention. Goodbye.